Now we've done quite a bit of curve sketching before, but not really with complex exponential functions that are a little bit tricky. So our curve sketching menu is quite helpful. We learned a whole list of letters here. I remember please do support ISA, children. You might have remembered it as some other little rhyme. Now, P is for prepare, then we have domain, symmetry, intercepts, sign, asymptotes, and here calculus, to which point I'm thinking the first derivative, the second derivative can help us with a lot of things. So prepare is, how can I rearrange this thing? Now it may be that you can expand brackets or you can factorise. If it's got fractions in it, perhaps you can make a common denominator. Some way of rearranging it. Now I can see that I can rewrite this as x over e to the power of x. And thinking of it like a fraction might just help me with some of these steps, so it's not a bad thing to do. Now as I go through these steps, I'm going to generate an awful lot of working. So in your book, I just keep on writing all the way down. I'm probably going to run out of space a few times here. At the same time, when you find things out, you can put them on your graph. So it's not a bad idea, I'll go right over the slide here, to have your graph ready to go so that as you find things out, you can put them on. All right, D is for domain. So let's think about what x can or can't be here. X is fine being anything it likes on the top of a fraction. What about down here? Can we do e to the power of anything we want? Yeah, we actually can. So it doesn't look like there's really any restrictions on x. I don't need to write anything down for this. It's just good to have thought it through. So I'm down now to thinking about symmetry. Why would you want to work out the symmetry of your function? Well, if you figured out what it looks like on one side and you know it's even, it would be really nice and easy to be able to just reproduce it on the other side. So sometimes it cuts down your workload. How do you find if a function is even or odd? Well, if you find, let's call this f of x. If you've got f of x and you investigate f of minus x or minus f of x, if these two are the same, your function's odd. If those two are the same, your function's even. And if neither of those things occur, then it's neither. So let's have a quick look. Subbing negative x in where they've got x there gives us minus x over e to the minus x. Well, that's not the same, so it's not even. And putting a negative in front of the entire function really just puts a negative in front of the x and gives us this. These are also not the same as each other. So therefore, I've found that it's neither odd or even. Okay, that's that step done. Okay, intercepts. Let's let y equal 0 and see what happens. If we let y equal 0, we've got 0 equals x over e to the x. Now the only way a fraction can equal 0 is if the denominator is 0. So this only happens when x equals 0. So we've just found a point that our curve goes through. It goes through the origin. So let's put that straight on there. It gives us a bit of confidence it's something we know. All right, what about if we let x equal 0? What happens? Well then, y is going to be 0 over 1, which also is 0. So it just gives us that same point again, another way. All right, we've thought about intercepts. The next thing to do is think about sign. What this means is we're wondering where the graph sits in space here. So we've got a bit of an idea how we can start to draw it. Now we've already found one point. It makes sense to me to think, well, what's happening over this side, say around to -1, and what's happening this side at around about 1. Just pick 2 points and have a look. So if I do a quick table of values here, I already know it goes through the origin. I can investigate a point to either side very quickly and easily. -1 here will give me -1 over e to the power of -1. Think about what that looks like. -1 over e to the power of -1. That's basically minus e, isn't it? Because I can rewrite this with the e up the top, e to the power of 1. So that's my working there. I'm going to get rid of that to save board space. I've got minus e. And if I sub 1 in up here, I'm going to have 1 over e to the power of 1. That'll be 1 over e. Now, quick thinking, e is around about 2.7 or so. So this point minus e, minus 2.7, it gives me some scale here. This is minus e. And I could actually label this point minus 1 minus e, and I've got a point on my curve. I've got this other point over here, 1 over 2.7. That's, round about a third or so. So if this is 1, it's going to be up just a little bit. I can also label this point 1 over e. So I'm starting to get somewhere already. I've got 3 points. It's looking like something of a curve here. All right, now I've thought about the sign. What about as it gets further along? I've got a few indicators of what it looks like just on either side of the y-axis. But what about when x gets really big and heads towards infinity up here, or really small and heads towards minus infinity down here? Let's think. Well, as x approaches infinity, y is going to approach infinity over e to the power of infinity. Now, we've already just seen that e to the power of infinity is really a powerful little expression. This is a big number. How can it be bigger than infinity? Well, this number gets big much quicker than this one. We say that it dominates it. And what that means is we've got a fraction here where the number on the top is going to be a lot smaller than the one on the bottom, and the difference between the two is going to be greater and greater the bigger the number is. So this actually approaches 0. So y is going to approach 0. Now it's going to approach 0 from the top because this is a positive number. So it's going to get to be a smaller and smaller fraction. Now I can draw this on my chart. I know that as I come up this way, we're going to get smaller and smaller and smaller. It's going to be coming down like this from above. I'm not quite sure what shape I need here, so I'll leave this section out. But now I've got 3 points, and I know that I'm sloping in towards the x-axis up here. All right, what happens down the other way as x is approaching negative infinity? Well, y is going to approach negative infinity. Oh, that's a terrible infinity symbol. Let's go again. Negative infinity over e to the power of negative infinity. Now, that looks a bit confusing to me. I'm just going to rewrite it. E to the power of negative infinity, I could rewrite that whole expression at the top of the fraction just by removing the negative in index. And I'd have negative infinity times e to the power of infinity. That makes more sense to me now. Infinity times this e to the power of infinity, that's just going to be massive. It's a hugely big number. And it's a negative, really big number. So I'm going to say y approaches negative infinity. Okay? So as I go down this way on the x-axis, I'm going to be going massively down this way on the y-axis. So I pretty much think I've got a point here. I can just show it going down at an angle with an arrow on it, because I know we're going to go onwards forever in this direction. All right, so I've thought about the sign, and I've got a lot of my graph sort of roughed in. Now I can think about whether there might be any asymptotes. Well, there's clearly none down this way, horizontal or vertical, because this is going on forever. And over here, we can see that we're approaching an asymptote at x equals 0, but it only exists out there for really big values of x. There don't seem to be any other asymptotes, and I can see from the shape here that I'm not expecting any vertical ones. So I'm going to leave that and move on to calculus.